Hello again. This is Dr. James Camp from Lee College in Baytown, Texas, and this is lesson 8 in my series on starting off in C++, where we're going to be talking about the struct data type. Now, why would we want to do structs? They let you store multiple related values for each item in a list. So if you had a list that, say, had an item name, an item price, and a quantity in an inventory list, that's one example. Another would be if you had a list of points that had an X, a Y, and a Z for each point in space in your in a model or a game or something like that, in some sort of 3D world. So there are all sorts of cases where you want to keep a list of items that have multiple properties to them. They also allow a function to return more than one value. So for example, you might have an X and a Y distance that you measure, and you want to return both of them at the same time. Or you have an area and a circumference for a circle, and you want to return both of them at the same time. Or you have a mean and a standard deviation that you calculate from a series of statistics, and you want to return both of them at the same time. As long as you define one struct that has both of those values in it, you can return that. If you're coming to C++ from a different language where they don't have structs maybe, or they don't use them very much, where it's a very object-oriented language, and so you would naturally just reach for making a class or an object. Structs can be lighter weight than classes or objects. You don't have to deal with privacy, the public-private divide. You don't have to deal with writing setters and getter functions, and you don't have to deal with writing any member functions at all, actually, because in C++ structs don't have them. All that said, a struct in C++ is simply a couple of data members stuck together. So in that sense, they're lighter weight, they're easier on the memory of the program than a class or an object. And perhaps more important than that, structs are backward compatible with standard C. If I'd never learned how to use a struct, if my C++ education had skipped me straight on over to classes and objects, then when I got to my C programming and Unix class in operating systems class in computer science, I would have had no idea how to program in C, because C doesn't have classes. That's why C++ has the plus, right? Okay, so our first project here is going to be an inventory system. We want to build a list in memory of inventory items, and then print the complete inventory to the screen when we're done. We know that each item has a name, a quantity, and a price. We could make 3 parallel arrays, an array of names, an array of quantities, and an array of prices, and just assume that everything at index 1 belongs to the same item. But keeping those lists synchronized is a chore, making sure that you populate all 3 of them in exactly the same way. So instead, we're going to build a vector of structs. So how do you define a struct in C++? Well, first you use the struct keyword. That's a reserved word in C++. Then you give your struct a name. Now, it is convention in C++, you're not required to do this, but this is what everybody does, that we start our struct name with a capital letter, and then each new word in the name of the struct gets another capital letter. We don't put the underscores in struct names. We use the capital letter for every new word way of doing things. Then you have an open curly, and then you have your list of field names, each one on its own line ending with a semicolon. Each one is declared just like a variable. You give it a type name and then a variable name. You can have as many field names as you want. You can have as few as you want, though it really doesn't make sense to only have one. Otherwise, why have a struct? And then note at the very end here that we do have a semicolon at the end of the close curly. This is different than function definitions or if statements or while loops. We have a semicolon here for reasons that have to do with how these things are implemented in C, where you define the struct name and then you can start listing variable names right afterward. And that list of variable names has to end with a semicolon. So then how do we use a struct? Once we've established struct name as a type, we can just use it to create a variable, my struct. If you want, you can then initialize in curly brackets each field of your struct. So if we have two fields X and Y, you provide the X value first and the Y value second. If we have three values, a name and a quantity and a price, you can put my struct open curly, a string for name, comma, a int for quantity, comma, and a double for price. My struct.fieldName1 equals, and you give it a value. So we use what's called dot notation to access the fields of the struct, and you can just directly assign each one a value. You can also just directly output individual field names or individual fields from the struct to see out. You cannot see out an entire struct at once. Notice that you can't do that. You can have a vector of struct name, okay, and then you can call myVector.pushback and just pass it a struct, a variable of type struct name, and that will work just like any other vector of any other type that we've studied. And you can access my vector at 0 would be the first struct in your list, and you can do that and then just put dot field name 1, and that gets you the first field in your struct. Okay, so let's write our program. We're going to start with the usual collection of headers plus the one for vectors. Before we start our main function, though, we're going to define the type struct item. Okay, a lot of people make the mistake of defining struct item inside the int main function. If you do that, then it's only accessible inside int main. It can't be used in any other functions. So it's important to define struct out in global space where it can then be accessed by any of your member any of the functions in your program. So we have struct item, open curly, string name, int quantity, double price. Note that they don't have to be of the same type to be part of a struct. And of course, we don't forget the semicolon at the end of the type definition. All right, now we get to int main, and the first thing we need to do is set up the data structures. So we're going to have an item that I'm calling this item that we're going to keep reading in from the keyboard. And then we're going to have a vector of items that I'm calling inventory. That's our actual inventory list. Note that now that we've defined it, item can be used as a type name either to declare variables or on the last line here to compose a vector. Okay, now we set up a loop to read the items for our inventory. The item name may have spaces in it, so we have to use getLine to read that item. But when we get to the quantity and the price, those are individual numbers, so we can read those with the CN greater syntax. Okay, but notice that a field of a struct is accessed like any other variable, or accessed using dot notation, and once you use the dot notation, it can be used like any other variable. So you can directly read in this this item.name or this item.quantity. Also notice that the pushback member function is going to make a copy of our struct and add it to the vector. So we can keep changing this item every time through the loop, and we keep making a new copy of it and adding it to the end of our inventory list. That's somewhat different from how this works in some other languages like Java or C#. Now we use the special for each loop to print out our inventory list. So notice that we can use item as a type in the for loop as well. So we can do for item : inventory, and then each time through the loop we get a new item. We can't print the item itself, the whole struct, but we can print item.name and then item.quantity and then item.price. And that ends up looking like this in the Visual Studio console. Okay. Our second project, I want to also demonstrate to you how we can use structs to return two values from a single function. So let's say we have a single function that operates on a cylinder that's going to return two values, surface area and volume. But that can't be done, you say. C++ functions return a single value. But a struct is a single value. So if we define one struct with two members, surface area and volume, we can return both of those values from a single function. So I'm going to define a struct. I'm going to name it something stupid like geom_vals for geometry values, and I give it two fields, surface area and volume. Note that they're both doubles. They don't have to be different. You can have different types in a struct, but you don't have to have different types. And then I define my function. So geom_vals cylinder, it takes height and radius as parameters. And then it does my calculation. So a couple of things to notice here. Our struct type can now be used as a return type for a function. So again, anywhere you would use a type like double or int, you can drop in your struct type. Note also that we do have to define a temporary variable inside the function so that we can give it values, result.surfaceArea, result.volume, and then we can return our temporary result at the end. Okay, so what have we learned today? We've learned how to define a new struct type using the struct keyword and giving it a capitalized name. We've learned how to use a struct type to accumulate related values in a list using a vector of our struct type. And we've learned how to use a struct type to return multiple values from a function by using the struct as a return type from that function. Okay. Now all that's left is for you to go and practice. So as always, good luck and happy programming.